here. So, bleaching is a chemical process to apply a cellulosic material to improve the brightness, right. And bleaching basically is any delignifying bleaching agents has two fundamental characteristics as far as bleaching is concerned. First is rapid removal of residual lignin present in the unbleached pulp, and an action of carbohydrate on cellulosic molecules must be slow compared to the action of residual lignin. These are the index of my presentation. Bleaching journal, objective of bleaching, chemical used for bleaching, type of bleaching reactions, chemical reaction and mechanism, bleaching chemical characteristics, auxiliary bleaching chemicals and conclusions. See, these are the objective of pulp bleaching. High brightness of pulp. Chemical grade pulp is able to achieve the high brightness more than 85%, and for mechanical and recycled fiber required to bleach the pulp around 70 to 75%, right. So, brightness stability is inversely proportional to the brightness reversion, and brightness stability can be achieved by removing the chromophoric groups structure. Chromophoric group, what is it? It is a molecules or part of the chemical molecules and that absorb the visible light or UV region light, and quinone 1 is the powerful chromophoric group present in the residual lignin. Basically, residual lignin difficult to remove by the nucleophiles, which is used by the pulping process. So, we have to add the some highly oxidizing or reducing agent to remove the remaining lignin from the pulp. So, high pulp cleanness is also very important to achieve the high brightness of the pulp, and that is the bleaching. Basically, pulp consists number of fibers, bundles, sieves, knots, and these little more the contaminated the pulp, and these contaminated should removed by the adding the chemical bleaching of chemical pulp step by step manner. High cellulosic content is also required. During bleaching, each and every stage the cellulosic content also degrade along with the removal of residual lignin. These objectives must be achieved without compromising the strength of the final product. Sorry. So, these are the two principal different method. One is a lignin removing bleaching, it is mainly for chemical grade fiber, and second one is a lignin preserving bleaching, that is mainly for a mechanical grade fiber. So, what we do in first, we break up the lignin present in the pulp molecule into the small fragment, and that fragment was water soluble by the next bleaching stages, and it is suitable for the chemical grade fibers. Lignin preserved bleaching, the lignin is not removed, partially low molecular weight of the lignin molecules removed in the semi chemical or mechanical grade pulp, but we declarize the chromophoric group present in the pulp, and it is mainly for use in a high yield pulp, that is a chemi-thermomechanical pulping pulp or semi or refiner mechanical pulp, TMP pulp, RMP pulp, say, and make the lignin brighter. You can see this one, this is a suspension of the fiber, aqueous suspension of the pulp fiber, and when we do bleaching, and bleaching is the residual lignin molecules start to break down or fragment into the small one, and on further extraction process it is start to solubilize. In the second process, this is a aqueous suspension of the fiber, and when we apply any oxidizing or reducing agent in it, and it decolorizes the color of the lignin molecules to brighten up to the 70 or 75% ISO brightness. So, these are the commonly bleaching chemicals are used for bleaching of chemical, mechanical or recycle grade pulp. Some are the few are oxidizing agent, reducing agent, and the oxidizing agent chlorine is a highly oxidizing agent, hypochlorite, chlorine dioxide, alkali, ozone, peroxide, complex agents, paracetic acids, bisulfite, dithionite, and enzymes also used not in commercial scale. Enzyme is in laboratory scale we use to enhance the 1 to 2 units of the brightness of the pulp. So, this is a oxidation equivalent. Oxidation, the oxidizing power basically expressed by the oxidation equivalent. The quantity of the substance to receive 1 electron per mole when the substance is reduced is called the oxidation equivalent, and these are the some bleaching agents which are used to bleach the pulp, that is chlorine, NaCl, chlorine dioxide, ozone, peroxide and O3, ozone, and ozone is a highly oxidizing agent. To it actually reacts the 6 electron per molecules to the lignin structure. Chlorine dioxide is 5 and then chlorine is 2. If we compare with the chlorine dioxide is 1 kg chlorine is equal to the 2.63 kg as active chlorine. So, chlorine dioxide is highly oxidizing compared to the chlorine, and ozone is the most oxidizing agent, and it is 1 kg ozone equals to the 1.7 kg chlorine dioxide. See the effect of bleaching agent on brightness and cellulose molecular mass. Bleaching response decrease with increased chemical charge. You can see the if we increase the chemical charge, in every stage the at the one point brightness start to in a linear direction. This is called the bleaching effectiveness. Bleaching effectiveness is achieved the maximum brightness can be achieved by the function of chemical charge and process conditions. Process condition should be optimum when we are going to bleach any type of pulp, whether the wood pulp, agro pulp or recycle pulp or mechanical grade pulp. And on the other hand, you can see when we increase the if we are adding to have the high amount of chemical pulp in the during the bleaching, the cellulosic molecular mass start to decrease at one point. So, we have to take care we have to add the bleaching chemical in a control manner, in a optimized manner, so that we can preserve the strength of the cellulose as much as in the pulp, and it will reflect on the final pulp, final paper of the in the final end of the product. So, bleaching cannot be performed in a single stage. So, multi-stage are required to achieve the target brightness level. So, 3 to 4, 5 stages are required to bleach more than 85% brightness. So, these are the common bleaching sequences. These are the different bleaching processes. One is a conventional. Conventional is a well known process, and in this process we use the molecular chlorine followed by extraction followed by peroxide, and then hypochlorite bleaching sequences, and then CEPHH, CEOPHD. These are a different conventional bleaching sequences which are used by the Indian paper industry. ECF, DPD, OD, EP, D, OD, and this is a substituting bleaching sequences, OD by C, EOPD, and OD, HOT, Z, EPD. And these are a total chlorine free bleaching sequences, no molecular chlorine or chlorine dioxide elemental chlorine are used by the TCA bleaching sequences. Only Z, P are we are using OZP, OZEPP, OAZ, EPPO. These are a sequence which can be used to bleach the chemical grade pulp. For mechanical grade pulp, we use chelation agent QP1, P2 and QPYP and QYP and PP. So these are a process variable conditions. Each and every stages of a bleaching process. For OD oxygen delignification process, we use the consistency around 10%, reaction time we kept 90 minutes, reaction time 90 minutes or pH alkaline in medium. So in chlorination stage we maintain 8 consistency, reaction time is 30 minutes, reaction temperature ambient. So different process variable condition we maintain in a optimum manner. Otherwise what happen, the cellulosic degradation will be fast and the strength of the pulp will drop very rapidly. So this is a chlorine free bleaching sequences of chemical fiber. Elemental chlorine free, chlorine is not allowed, but other chlorine containing chemical like chlorine dioxides are allowed, and ECF light. Most of the mills are using ECF light sequences, like ITC Bhadrachalams are using ECF light sequences where ClO2 charge has been reduced by substituting chlorine free bleaching for ClO2 in one or more stages, and sequences are OZ, EOP, DEP. Total chlorine free bleaching process, neither chlorine nor other chlorine containing chemicals are allowed, only Z stage. It is this sequence is mainly used for a food grade product. Suppose we want to make food grade pulp product, pulp from the food grade quality of paper, so this type of sequence we use. So this is a reaction mechanism. 3 type of bleaching reaction mechanisms occur during chlorination: electrophilic reaction mechanisms, nucleophilic reaction mechanism, and third one is a radical reaction mechanism. In electrophilic reaction mechanism, these chemicals are used, that is chlorine, hypochlorous acid, ozone, chlorine dioxide, and paraacetic acids. In nucleophilic reaction mechanism, sodium hydroxide, hydrogen peroxide, hypochlorides and paraacetic acid also used. Radical and chlorine dioxide and ozone basically when react with the pulp and they generate the radical. Some radicals are favor the reaction and some radicals are unfavor the reaction. Some radicals react with the lignin structures present in the pulp, but some radicals basically degrade the carbohydrate very in a fast manner. So this is a electrophilic attack on the lignin. These are lignin molecules. Lignin basically 2 type of mechanism. One is the electrophilic, another is a nucleophilic. Electrophilic reaction mechanism, electrophilic initiate the lignin degrading bleaching process and it will attack to the electron rich lignin structure and involve as a cation, right? And these are a major attack of the electrophile in present in the lignin. This is a ortho para and meta position. The any cation attack to the in a very very fast manner, and these are a minor attack. Dot dot structure, if you see, this is a minor attack, and this is a cellulosic monomer, and two type of reaction occur during react with any electrophile react with the cellulose molecules in a two way. One is a random chain cleavage, and another is a another endwise peeling reactions. And this is a nucleophile attack on a lignin, and it is a lignin preserving bleaching. Basically, it nucleophile attack to the electron deficient site of the lignin structure in a alkaline medium and involve as a anion, and it react to the carbon carbonyl and conjugated carbonyl compound of the lignin structures. So, if we compare bleaching versus pulping, so it is a delignification process, more selective in terms yield and DP, is more expensive per unit of lignin remove less lignin, produce problematic effluent. So, first bleaching stage is a pre-bleaching stage is a oxygen delignification. During oxygen delignification, the 40 to 45% lignin can be removed by the oxygen process and minimize the pulp degradation. Cellulose loss is also we can minimize the bleaching chemicals, reduce the amount of lignin to be the bleach plant, minimize if environmental load, reduce bleaching chemical demand. So, this is a stepwise reduction of a oxygen to water. The electron reductions and the electron reduction transform oxygen to peroxyl radical, then to hydrogen peroxide, and subsequently in the hydroxyl radical, and finally make the water. These superoxide anion radical and hydroperoxy anion are basically highly oxidizing radicals, and it basically attack to the lignin molecules present in the pulp, and it is basically these two basically lead to the these two radical leads to open the radical structures and of the lignin structures, and oxyl anion radical on the other hand, oxyl anion radical hydroxide ions are unselective towards the lignin removal. See, this is a oxygen and the lignin reaction. Phenyl hydroxyl group present in the lignin molecules basically react with the oxygen in a alkaline medium, converted into the phenolate structure, and phenolate structure again react to the oxygen, and it convert into the resonance stabilized phenoxy radicals, and also form the superoxide radicals, and also produce byproducts carbon dioxide, organic product, and low molecular weight of organic compound by beta elimination side elimination reactions and demethylation reactions. So, this is a chlorination stage. First bleaching stage, it is mainly for a chemical fiber. Chlorine is a very good delignifying agent, low cost, highly reactive nature, and within 5 seconds it react with the pulp, and very effective selective bleaching chemical, and during chlorination 10 to 15% pulp viscosity goes down during chlorination, and it is ability to remove the to dirt particle bundles of sieves of the fiber, and reaction with lignin are substituting reactions and electrophilic displacement reactions, oxidation reaction, catalytic hydrolysis reactions, electrophilic addition reaction to the carbon-carbon double bond. During substitution and electrophilic addition reaction, and it is basically lead to incorporation of the chlorine atom attached to the lignin structure present in the pulp and to form the chlorolignin compounds, and also generate the toxic chemicals like TCDD and TCDDF. These are a carcinogenic material basically compound and which generate during chlorination, and the effluent of the chlorine after chlorination, it is toxicity in case of chlorination if effluent is very high. So, this is a effect of how pH effect during chlorination. Basically, this is a chlorine water system. In chlorine water system, basically exists in the three form. Number one is a chlorine, hypochlorous acid and perchlorous acids, right. At pH 5, the concentration dependent equilibrium exists between the chlorine HOCl. Once the pH start to proceed in the higher direction, then the OCl compound start to form, and it also decrease or degrade the cellulosic molecules present in the pulp in a very rapid manner. So, we have to take care that pH should not be higher, should not be higher on higher side in when we are doing to bleach the pulp with chlorination. pH should be always be kept less than 2. Extraction stage, to remove the chlorinated and oxidized lignin perform in the chlorination stage, dissolve 80% residual lignin removed in the early stages to remove the physical barriers. What is the physical barrier? Some blocking compound are formed during chlorination, and during this extraction stage these blocking groups are again reactivate for a further delignification to generate the new active groups on remaining lignin structures, allow lignin with the oxidizing agent used in the next stages to remove resins and fatty acids during extraction stage. An oxidizing bleaching chemical O2 and H2 is often added as a reinforcement to enhance the delignification and selectivity of the chemical. So, O and P reinforcement extraction denoted by EO, EP and EOP. Increase delignification during extraction, increase brightness during extraction, reduce chemical consumption in later bleaching stage, less color infiltrate, 5 kg ton oxygen and 1 kg ton of peroxide can be able to replace the 3 kg per ton chlorine dioxide charge in the D1 stages for a similar brightness. So, this is a hypochlorite stage. It is a brightening agent and it can remove or decrease the chromophoric group present in the final pulp. At high pH, basically the carbonyl and carboxyl groups and conjugated carbonyl are start to form. So, we have to take care during hypo stage, pH should be around 10.5 to 11, not more than that, and temperature also we have to maintain 40-45. If temperature will be high, degradation will be fast. So, these parameter, these process variable should be optimized in a proper way when we are going to bleach the pulp. So, this is a chlorine dioxide stage. Chlorine dioxide is again it is a very good delignifying agent, very selective compared to the chlorine, and it basically specific attack to the lignin molecules, and it attack phenyl propane units, phenolic hydroxyl structure present in the lignin, as well as non-phenolic structure also. It has a capability to attack the carbon-carbon bond molecules present in the lignin structure, work as a radical scavenger, thereby protected cellulose against depolymerization, used for initial ligninification and final bleaching. Compliance with strict environmental regulations. So, this is a react fastest, preferably with phenolic lignin structures. React slowly with a non-phenolic lignin structure, and degrade lignin form mucinic acid type structure. It converted the phenolic lignin structure and lead to open the aromatic structure of the lignin and converted it into the mucinic acids. So, this is the advantage. We can achieve high brightness of pulp by adding chlorine dioxide in the final stage, excellent for sipes and dirt removal, substitute to harmful chlorine and hypochlorite. High strength pulp can be achieved by adding D in place of C. Brightness stability, basically brightness stability, we can the conversion of when we store any pulp for a longer period of time, then brightness start to revert back. So, if we are using DEPD bleaching sequences to bleach the pulp and compared with the conventional bleaching sequences, brightness stability is higher in case of the elemental chlorine free bleaching compared to the conventional one. So, this is a ozone bleaching sequences. It is for mainly chemical grade bleaching for chemical fiber. It is a total chlorine free bleaching produced on site from oxygen 12% weight by weight. 1 kg ozone can generate we can generate 1 kg chlorine by using 8.3 kg oxygen and consume around 8.3 kilowatt per hour energy. Suppose we want 1 kg ozone to produce 1 kg ozone, so we required around 8.3 kg oxygen and 8.3 kg energy. Strong oxidizing agent, and it is highly reactive, fast in nature, somewhat poor selectivity. If we compare with the chlorine dioxide, and it is less selective than the chlorine dioxide. Normally early in the bleaching sequences can be used in the combination with the chlorine dioxide. Ozone is an oxidizing electrophiles reagent which can oxidize free phenolic hydroxyl lignin structure present in the pulp, non-phenolic and conjugated double bond of the lignin structure. So, this is a ozonation reactions, and number of byproducts are formed during chlorinations. So, benefit of the ozone bleaching: ozone is 10.6 times more reactive towards lignin than towards carbohydrate. Removal of hexane uranic acid present in the pulp, and it is basically the responsible compound to brightness sealing. Brightness sometime we can able to achieve the high brightness due to the presence of the hexane uranic acid, and it has this chemical has ability to remove the hexane uranic acids, uh, if present in the pulp. Extractive content also significantly reduced by adding ozone. Brightness also, good brightness stability can be achieved by adding ozone. Unfortunately, radical formation, basically some radicals which is very harmful for degradation of carbohydrate. Addition to additive to retard the carbohydrate decomposition of pulp. Compliance with strict environmental regulation. No AOX generated during ozonation, ozone reaction. Hydrogen peroxide, and this chemical used for a chemical or mechanical both type of grade of pulp. Some what different process condition. For peroxide we normally use in the alkaline medium, and we maintain pH around 10.5 to 11, and we kept the temperature, keep temperature around 70-75 degrees Celsius for 60 minutes, and it is totally chlorine free bleaching chemical, widespread use in TCF bleaching sequences for chemical pulp, less effective for delignification compared to the ClO2, very effective in the final bleaching, work under alkaline condition. Reactive species are pre-hydroxyl anion. So, this is a bleaching chemical characteristics. Bleaching chemical characteristics are equivalent weight, efficiency, reactivity, selectivity, dirt removal, and environmental implication. And these are bleaching chemicals. And you can see carbon dioxide is efficiency wise. Efficiency means selectivity means removal. The ratio is removal of lignin and the removal of carbohydrate. This is called as a selectivity. Reactivity means towards how much lignin is removed by the adding of the any bleaching chemicals, that is called as a reactivity. Efficiency में कितना lignin आपका remove हो जाता है. And then this is a low environmental implication in case of the ozone is low and moderate in case of ClO2. In chlorination, high efficiency, high reactivity, high selectivity, dirt removal is high, and environmental implication is very also high. So, these are the auxiliary chemicals and their reaction function in bleaching. Acid basically is able to remove the hexane-uranic acids. If we use acid stage before ozone, then we can able to remove the hexane-uranic acid group by acid hydrolysis. Alkali dissolution of oxidized lignin residue after the first bleaching stage. Chillants, removal of the transition metal. Basically, it will decompose the bleaching chemicals, like when we add hydrogen peroxide for a mechanical for bleaching process. So, first we have to do the chillation is essential to required to save the chillants for save the decomposition of the bleaching chemicals. Xylenase, degradation of surface lignin carbohydrate complexes. So, this is a conclusion. For chemical bleaching of a pulp, the main reaction mechanism is oxidation. For mechanical bleaching of pulp, describe the decolorization of chromophoric group of lignin. It is important to remember that depending on a bleaching condition, different intermediate products are formed. Reaction of bleaching chemicals are often very complex due to the formation of intermediate product. Thank you. Yes.
Very interesting talk. I have a lot of chemistry is there on bleaching. Just sir, I want to know particularly for one example.
Yeah.
The industry is producing, for example, printing grade paper. You have mentioned that bleaching is a multi-step process. Multi-step. So, how many steps are bleaching process are used in a industry nowadays, and what is the total duration of the bleaching if you consider multi-step bleaching, and what is the total water requirement in the bleaching? For example, if you say 1 kg of raw material, how much bleaching is, or 1 kg of pulp, how much your water is required to produce the final
Uh,
bleached pulp?
no, in totality, I am talking about the total water consumption by the Indian paper industry. For integrated paper mills are using 30 to 40 meter cube per ton of paper, right? And for recycling grade uh, paper mills are using hardly 10 meter cube per ton of paper, right, for producing the 1 ton of recycled pulp, final pulp, right. So very less amount of water are being used by Indian paper industry, and only EOP stage the water are going to the ETP plant.
And total bleaching time, what is the duration? If you consider
Duration time
multi-step bleaching, what is?
for a each and every bleaching chemicals has a different duration of time, reaction time. For example, in chlorination only 30-minute duration time for a reaction time, say. ODL is 90-minute, and few mills are using 60 to 70-minute depending upon the end quality of the product, right. For example, if I talk about the dioxide, we in a during first stage of D we maintain 60 minute, in final stage of D we maintain 180 minute, and industry are maintaining 2.5, but in the laboratory scale we maintain 180 minute to complete the reaction, because dioxide is very selective towards lignin, and it will very less amount of carbohydrate degrade during chlorine dioxide stage.
Okay, sir. Thank you.
pH is very important to maintain during chlorine dioxide. Na? So, in first stage we maintain 2.5 to 3 pH, right. If pH will move up, and when we perform the first stage of bleaching, then what happen, the chlorate formation start to form. Two type of product will form, one is a chlorate and another is a chlorite. Chlorite actually favor the removal of the lignin, but chlorate formation take place and the efficiency of the chemical will go down. So, you will not get the optimum level of you can say the achieve the final product reduction in terms of brightness in kappa number or improvement in brightness. So, pH we have to maintain very carefully in D0 stage 2.5 to 3, and should not be greater than much. But in the final stage of D, we can maintain pH around 3 to 4 on a higher side.
Sir, there is a one tabular format you have shown in bleaching.
Yes.
Bleaching, particularly characteristic,
Yeah.
where you have mentioned low, medium, or high.
Yes.
Is there any magnitude or value over there?
Value.
Magnitude or value, something. Say, for example, low means 10 to 20%, medium means like that.
In terms of selectivity and
Yeah.
based on the pulp characteristics and effluent characteristics, we have given the high, low and medium, moderate, medium characteristics of each and every bleaching chemical.
But,
suppose in case of ozone, low environmental implication means no AX generation, almost 0, right, if we are using Z, right. And in case of carbon dioxide, it is a medium environmental implication will come, means, and we will we can able to achieve 1.5 times lesser environmental implication compared to the chlorine, right. So based on this, we have given low, medium, medium and high this mark in our table.
Okay.
Bleaching through ozone, is
Yeah.
it economically viable? That means most of the paper industry, they are using chlorine
Yeah,
for bleaching process.
yes.
So, is the bleaching through this ozone, is it economically viable, or is it available abundantly?
Ozone are being used by ITC Bhadrachalam. One of the paper mills right now are using ozone bleaching, but in the coming days, it is I think will be mandatory for a, suppose we want to make the food grade product. So we are essential to produce the chlorine free paper, right. No chlorine compound should enter in the paper. So it is in a coming days, maybe it will be mandate, right. But if we compare the cost wise, there is no much difference between the ozone and carbon dioxide. Of course, carbon dioxide is slightly selective nature compared to the selective compared to the ozone one, but both are good bleaching agents.
Okay, thank you, sir.